Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at calculating the sum of a limiting geometric series. But before we get to that, we need to understand what do we actually mean by geometric. So a geometric sequence is one in which each subsequent term is multiplied or divided by the same number, meaning it has a common ratio. What does that mean? Well, each of these here is sequences. It's just a whole heap of numbers written one after the other. Each of the individual numbers is called a term. So let's identify for each of these four sequences whether or not it is geometric. So geometric means that with each subsequent term, you're timesing or dividing by the same amount. So here, from 5 to 20, I times by 4. And then from 20 to 80, I times by 4. From 80 to 320, I times by 4. So this here is a geometric sequence. Here we say R is 4. R is the common ratio. 4 is the value you'd get if you took any term and divided by the term before it. This is geometric because each time I'm timesing by 4. On the other hand, if I look at this sequence here, it is not geometric. I'm adding 6 each time, but I'm not multiplying by the same number. If you put 19 divide 13 on your calculator, you'll get a different answer than 13 divided by 7. So this sequence here is geometric because I'm actually timesing by the same amount each time. I'm actually timesing by negative 1.5. If you were to take any term and divide the previous term, you'd get negative 1.5. Negative 27 over 18 is negative 1.5. 18 divide negative 12 is negative 1.5, and so on. So this here is geometric, and R is equal to negative 1.5. This sequence here is also geometric because I'm actually dividing by the same amount each time. To go from 1 over 8 to 1 over 24, you actually divide by 3. If I want to go from 1 over 24 to 1 over 72, you divide by 3. So this is geometric. R is actually 1/3 because R, the common ratio, is what you're multiplying by. If you do this number divide this number, you get a third. This divided by this is a third. This divided by this is a third. Of course, dividing by 3 is the same as timesing by a third. So this is geometric. R is a third because if you start at any term, you times by a third to get the next term, and then times by a third to get the next term, and so on. So that's what makes a sequence geometric. Now let's look at a geometric series. So consider the sequence half, a quarter, an eighth, a 16th, and so on. That is a geometric sequence because I'm multiplying each term by a half to get the next term. Now, if I add up all of these terms, it becomes a geometric series. Now, these dots mean it goes on forever. I'm actually going to add infinitely many terms of this sequence. So you might think to yourself, well, surely if I'm adding infinitely many terms, the answer is going to be infinity. The sum is just going to get larger and larger in an unlimited way as I add more terms. But it's actually not the case. So half is 0.5. Add a quarter, you get 0.75. Add an eighth, you get 0.875, 0.9375, 0.96875. You can see that the sum of the terms is sort of slowing down, and that's because each term is getting smaller and smaller. If you kept on adding terms infinitely long, you would end up with an answer of 1. What that means is if you keep adding numbers here, the sum will get closer and closer to 1. This is what we call a limiting sum. 1 is the limit of this sum. No matter how many terms of this sequence that you add up, you will never exceed an answer of 1. Now, this is not the case for this series here. 2 plus 6 plus 18 plus 54. You can see clearly that the terms are getting larger. In fact, they're going to get larger very, very quickly. So if you just keep adding terms of this series, it's just going to get larger and larger. It will be infinite. If you add infinitely many terms of this series, you will get an infinite sum. So why does this have a limiting sum and this one didn't? Well, it's all to do with the R value. In this series here, R is equal to 3. If you take a term, you multiply it by 3 to get the next term. So what actually happens is that a limiting sum exists if and only if R is between -1 and 1. That's why this had a limiting sum and this didn't. See, if R is between -1 and 1, that ensures that each subsequent term is getting closer to 0. And that means that the more terms you add, the terms are becoming so much smaller. They don't add as much to the total. So if there is a limiting sum, we write it as S infinity, the sum of infinitely many terms, and the value of that sum is A over 1 minus R, where A is the first term. So if we look at something like this is geometric and will have a limiting sum. The reason is, how you can tell quickly, is the R value is equal to -1 over 3. If you're not sure of the R value, take any term and divide by the previous term. -8 divided 24 is -1/3. -72 divided 216 is -1/3, and so on. So we know that it has a limiting sum. So what will be the limiting sum? Well, the sum of infinitely many terms, that is the sum, if I keep adding terms over and over again, is always equal to the first term divided by 1 minus the common ratio. So here it's -1/3. So you can put that in your calculator and you get 162. So 162 is the limit of this sum. If you keep adding terms over and over again, they will converge to a sum of 162. This geometric series has a limiting sum as well. We can tell that by finding the value of R. If you don't know R, take any term and divide the previous term. So here the value of R is actually 1/4. So there will be a limiting sum. That means if you keep adding more and more terms, you add infinitely many terms of this sum, it will be equal to first term divided by 1 minus the common ratio. So again, you can use your calculator. That just gives you 1/3. So this is a very important example of a limiting sum, because we're going to use that when we look at recurring decimals in different bases. But for now, let's look at some harder questions involving limiting sums. So here we have the sum of an infinite geometric series that reaches a limit. So we're going to use the formula for limiting sum to find the value of A. So that formula tells us first term over 1 minus common ratio is equal to the limiting sum, in this case 7.5. Now note here that the value of R is a fifth. Each time you take a term, you divide it by 5 or multiply by 1 over 5 to get the next term. So I'm going to replace R with 1 over 5. So of course, 1 minus 1 over 5 is equal to 4 over 5. So A over 4 over 5 equals 7.5. Now this fraction line means divide. And the way we undo dividing by 4 over 5 is simply 2 times by 4 over 5. So A is just 7.5 times 4 over 5. You can use your calculator and you get the value of 6. All right, let's do this one. So x plus x squared plus x cubed and so on gives us 1 over 6. So this is a geometric series. The first term is x. The common ratio is also x. If you take any term, divide by the previous term, you get x. So we have x over 1 minus x equals 1/6. So what we're going to do is cross multiply x by 6, 1 minus x by 1. I get 6x is equal to 1 minus x. Adding x to both sides, I get 7x equals 1, and therefore x is equal to 1 over 7, and I'm done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.